Now, so for this question, okay, I have actually have a chicken egg. Okay, you have a chicken egg, and then they make up. Okay, they make up to, okay, let's say they make up 5% of the mass. Okay, the shell is 5% of the mass of the egg. Okay, assume that this is 50 gram. So if it is 5%, okay, 5 over 100 times 50, you are going to get 2.5 gram. It means 2.5 gram is the mass of the shell. And then they say the shell, okay, is actually made, okay, is made from calcium carbonate. Okay, it's made of calcium carbonate. So that is going to be according to the question. Okay, they say that how many complete chicken egg shell will be needed to neutralize 50 cm cube of 2 mole per dm cube ethanoic acid. So we need to actually find out this. Okay, so how many? Okay, this one is quite simple. Okay, you can actually find out. Okay, ethanoic acid. Yeah. Okay, maybe for now you do not know what is the formula for ethanoic acid, but later, okay, you will actually it will be very familiar with you. So I will just write down the formula CH3COOH. Okay, that is ethanoic acid. So from here, okay, they say that ethanoic acid they have given, okay, 50 cm cube and then 2 mole per dm cube. Okay, using this we need to actually calculate. Okay, so let's actually calculate. Okay, so first of all, what you need to do is to calculate, okay, calculate the number of moles of ethanoic acid. Okay, number of moles, you get 50 times 2, okay, divided by 1000. Okay, CV over 1000. So you will get 100 over 1000. So you will get 0.1 mole. And then they say it's going to be neutralized. So do remember, we are talking about calcium carbonate. So when this one added with calcium carbonate, what will happen? So I'll erase this part. So I need to write down the equation for this. Okay, any acid, okay, any acid, when they react with carbonates, okay, they will actually give you salt and carbon dioxide and also water. Okay, do remember this. So if I write down over here HCl, if you react with calcium carbonate, you are going to get calcium chloride. Okay, calcium chloride, and then H2O and carbon dioxide. So we need to balance it. Okay, so the same thing over here. Okay, we need to actually do the same thing where, okay, when we have calcium carbonate, what will happen? So the same, do the same. This is going to be the acid is H. Okay, so this one is the ion. Okay, the ethanoic ion. So we have calcium. Calcium is 2 plus. And then you have CH3COO minus. Okay, so it's not balanced yet. So we need to actually balance this. Okay, you need to actually times this by 2. So it means it's supposed to be calcium, then CH3COO, then 2. Okay, but okay, for this case, okay, it's supposed to be like this. Okay, but for only for this kind of salts, okay, ethanoic salts, the way we write is slightly different. They actually write CH3COO 2 and then they put Ca over here. Okay, Ca over there, but it's still the same. Yeah, okay, it's still the same. Okay, no need to worry so much about this. Still the same. So plus carbon dioxide and water. So what's next? We need to actually learn how to balance them. So when we balance this, okay, so you have 2 there. So I will put 2 here. Hydrogen, that's 2. Okay, hydrogen is 2. Let me just check. Okay, carbon. Okay, carbon is 1. Okay, oxygen, you can count 4 oxygen here. And then 2 oxygen and 1, so total 7 oxygen. So 3 oxygen and then 4 here, so 7 oxygen. So everything is balanced. So the next step is, okay, the next step is we actually we calculated 0.1 mole. That is actually the ethanoic acid. So this is 0.1. So the next is, okay, we want to find out the calcium carbonate. So this is 2. So this will be 1, ratio 2 to 1. So this one should be half of it, so 0.05. Okay, so once you have that, that is going to be the number of moles. Okay, we can actually calculate the mass. Okay, the mass is going to be number of moles equals to mass over mr. Okay, so what we need to do is, okay, we need to actually find the m. Okay, it's going to be n times mr. Number of moles is going to be, for this is 0.05. Okay, the mr. Okay, can someone help me to calculate the mr for calcium carbonate? Mr for calcium carbonate.
100.1.
100.1. So calculate for me what is the mass.
5.005.
5.00. Okay, is that correct, Arwen?
005.
Okay, that's gram. So we know that, okay, for every 1 egg, the shell makes 2.5 gram. So what you need to do is you just need to take 5.005 gram, divide by 2.5. Okay, you will get roughly, the answer is going to be 2. Okay, so the answer is going to be 2 there. Hope this one is clear. Okay, we will move on to the next question. Okay, this one is going to be a little bit more, I think, more in depth. Okay, there's a lot of, let's see how. Okay, so we are going to have, okay, we are going to have a sample of K2O. Okay, I'll give you time also. I will also write down the information over here. I will also give you time. Okay, please actually digest or read the question. Okay, stop you for now. Okay, you can see that, okay, they have K2O. They dissolve in distilled water. Then after that, out of that 250 cm cube, they take 25 cm cube. And then after that, they actually react with H2SO4. And then, okay, you will have something. So they are asking what is the original mass of K2O. Now, in order to answer this, okay, do remember K2O, when they are added with water, okay, you need to know this. They didn't give you this. Okay, potassium oxide, when it is added with water, any oxide, metal oxide, when they are added with water, they are going to give you KOH, the hydroxide. Okay, this is the thing that you need to know. Okay, potassium hydroxide. So what you need to do, you need to just balance this. Okay, so just balance this. You just put, okay, 2 over there. Okay, then it's already balanced. So it means that when you take, when you put 250 cm cube, it means we are talking about potassium hydroxide. When you take the 25 cm cube, it means they are talking about potassium hydroxide. So now when they actually do this reaction with sulfuric acid, what actually happening is they are going to react, okay, KOH with H2SO4. So I will just put KOH plus H2SO4. And you are going to get, okay, this is going to be acid with base, okay, or acid with alkali. You are going to get the salt, okay, KSO4. So K2SO4 plus water. Okay, salt and water, neutralization reaction. So the next thing you need to do is to balance the equation. So you balance the equation, there's K2, so just put 2 there. and then sulfate, everything. Okay, just check whether everything is balanced or not. Okay, there's 2 O, so I need to put 2 there. Hydrogen, 4 and 4. Everything is balanced over here now. Now, so the next thing that I need to do over here, so just to avoid confusion, I will erase this. Okay, the next thing that I'm going to do over here is to find the number of moles of H2SO4 because they have given you this data. So what we need to do is just N equals to 2 times 15 divided by 1000. So you will get 30 over 1000, 0.03 mole. So if I have 0.03 moles here, okay, sulfuric acid, what is the number of moles of potassium hydroxide? The number of moles of potassium hydroxide will be double because 1 to 2. So 0.06. Okay, that's going to be the number of moles of potassium hydroxide. It means that in 25 cm³ of potassium hydroxide, there are 0.06 moles. But do remember, when we have a lot of potassium hydroxide, we only took a small portion of 0.06. The remaining portion, which is going to make the 250 cm³, okay, we need to actually times with something. Like for example, if you're taking only 25, if you want to change it to 250, you want to find the entire thing, that will be, okay, you need to times by 10. Okay, you need to make it to 250, the remaining balance. Okay, so the remaining balance, you are going to get 0.06 times 10. That is going to be 0.6 mole of potassium hydroxide. Okay, I hope you understand up to here now. Okay, so I'll erase 0.06. Okay, that actually means this is going to be 0.6 is potassium hydroxide over here. So do remember, we are looking for potassium oxide. So if you look at the first equation that we have written just now, there's 2 to 1. So now the number of moles is 0.6 divided by 2, 0.3. So the next, what we need to do is to find the mass. Quite simple. Okay, number of moles. Okay, I'll erase some parts here. Okay, so what I need to do over here is I just need to find the number of moles. Number of moles is 0.3 equals to mass over mR. Okay, the mR of K2O. Okay, can someone actually find out the mR of K2O?
94.2.
Please repeat again.
94.2.
Okay, so the mass is going to be 0.394.2. What do you get?
28.3.
28.3. So that's going to be your answer. Okay, we will actually move on to the next question. Okay, like just now, I will actually let you figure out. Okay, please actually go through this question for a while. Okay, I'll stop you now. Okay, please actually check. Okay, I have actually summarized this question, okay, in this information here in front of you. So ferrochrome is actually alloy of iron and chromium. So what they have done, they actually they say that this Fe and Cr, when they dissolve in dilute sulfuric acid, they will actually form this one and this one. Okay, and then they say that FeSO4, they will react with this using this following equation. Okay, and then they found out that, okay, according to this equation, this amount will be required. So now they said that out of this 1 gram, what is the percentage of Fe? Okay, they want you to find the percentage. So in order to do this, we need to actually work backwards. Okay, we have to actually move backwards. So in this case, okay, what we do here is we have to find out, okay, first of all, okay, the number of moles of K2Cr2O7. So please, let's actually do that. Okay, number of moles of K2Cr2O7 is going to be 13.1 times 0.1 divided by 1000. So 1.31 times 10 negative 3 moles. Now, what do I know about this K2Cr2O7? I know K2Cr2O7 gives 2K plus Cr2O7 2 minus. It means that every 1 mole will give you 1 mole of this. Okay, why I'm actually doing this? Because they have actually mentioned in this form only. Okay, they didn't include K. So I just want to show that whatever number of moles that we have, which is 1.31 times 10 negative 3, must be the same as over here, which is 1.31 times 10 negative 3, which is 1.31 times 10 negative 3. So from here, what I can do here is I can find out, okay, what is going to be the number of moles of Fe2 plus. So the number of moles of Fe2 plus will be 6 times 1.31 times 10 negative 3. Okay, can someone help me to calculate this?
7.86 times 10 power of negative 3.
Okay. Now, I know that Fe, when you dissolve with H2SO4, they supposed to give you FeSO4. Okay, metal with acid will give you the salt and hydrogen gas. Even though they didn't mention, you need to know this and make sure it's balanced. And I see over there, it's all balanced. Okay, so why I'm doing this? Because I know that FeSO4 over here, FeSO4, they're supposed to give me Fe2 plus and SO4 2 minus. It means that, okay, I know the Fe2 plus, if this is 1 mole, this will be also 1 mole. Okay, so I found out that this one is 7.86 times 10 negative 3. So I know that this one is also 7.86 times 10 negative 3 as well. So what does it mean? It means this is 7.86 times 10 negative 3. Okay, to make it better, I'm going to erase this part. Now, what is our next step? Okay, so of course, I'm looking for Fe. So I know that 1 mole gives me 1 mole of this. So please actually refer back. So it's going to be 7.86 times 10 negative 3 moles. Okay, so we need to actually find out the mass. Okay, the mass is going to be N divided times AR here because it's Fe. So it's going to be 7.86 times 10 negative 3 times, what is Fe? AR of Fe?
55.8.
50?
5.8.
I cannot hear clearly. 50?
55.8.
Okay, 55.8 So please actually let me know about the mass when you times how many grams.
0.43859.
Okay, you get this. Now it means that, again,
0.43859.
now, so now we know we actually use 1 gram. Okay, please find out what is the percentage. Okay, so 0.43859 over 1 times 100%. So you will get 43.9%.
Sir, why use 1 gram, sir?
Again,
Why use 1 gram?
because they say that they have used 1 gram of ferrochrome.
Oh, okay, I didn't see.
So out of that 1 gram of ferrochrome, we know that this gram belongs to Fe. It means the remaining 1 gram minus this value will be giving us the mass of Cr. Or if you want to change it into percentage, it will be 56.1. Okay, you will get 55.1. Okay, 56.1. Yeah. 56.1%. Yeah. So I hope you can actually understand this. Yes. Okay. It's a kind of a confusing question, but that's why we want to discuss. Okay. That's why we want to discuss. Okay. Please actually take note of all this as well. Let's actually try another one here. So they have magnesium nitrate. Okay. Magnesium nitrate will decompose. Okay, this one later you will also learn. Magnesium nitrate, when they decompose, they already give you a white solid. It's actually MgO. Okay, the oxide plus a mixture of gas. The mixture of gas is NO2. Okay, plus O2. Okay, those are the gases that will be released. So what we need to do is to just balance the equation. Okay, so please balance the equation. There's 2 nitrogen. I put 2 there. Oxygen, there's 6. Okay, so this one I need to put half. So I just times everything by 2. I'm going to get 2 MgNO3, 2 MgO plus 4 NO2 plus O2. Okay, this is going to be my equation. Now, once you get this, okay, they say that one of the gas released is an oxide of nitrogen X. So this one, this is X. So they say that 7.4 gram is heated until no further thing. Then they ask you to find the mass of X. So if this one is going to be 7.4 gram, so please find out the number of moles first. Number of moles of magnesium nitrate. 7.4 divided by MR. Okay, please someone calculate for me the MR. MR of MgNO3 2.
$148.3.
Okay, so it's divided by 148.3. So what is the number of moles?
Zero point
0.05 approximately.
Okay, 0.05. Is that correct, Ewan?
Yeah.
Okay. So if we actually take, I put over here 0.05 here. Okay. We are looking for X, so 2 to 4. So it means double, yes. So 0.05 times 2. So that's going to be 0.1. Okay, that's 0.1 mole. So I want to find the mass. The mass is going to be number of moles times MR. Number of moles is 0.1. MR, we are talking about the MR of NO2. Okay, so what is MR of NO2?
86.
86.
46.
46. So you get 4.6 gram. Okay, it's much more easier. Yeah, straightforward. Yeah. Next question. Okay, we try to actually cover as many as possible. Okay, so that you can actually be clear about the question later. Yeah. Now, a washing powder contains sodium hydrogen carbonate, one of the ingredient. During titration, they actually use 1 gram of washing powder. Requires certain amount of sulfuric acid. Okay, so that is the only one will react with acid. What is the percentage of by mass of sodium hydrogen carbonate? Okay, in the washing powder. Okay, so let's actually do this. Okay, so here we know that sodium hydrogen carbonate is going to react with sulfuric acid. So what do we get? Okay, so if you are not sure, okay, just straight away follow this one. Sodium sulfate. Okay, plus something, hydrogen carbonate. Okay, they will give you carbon dioxide and water. So this one you must know. Okay, you can always guess. Okay, HCO3 will give you this. Okay, then after that, please actually balance this equation. So how do we balance? Please check. Okay, SO4 is balanced, so Na2. So I just put 2 there. So this one will become 2. Hydrogen will be 4, so 2. Oxygen 2, 4, and 4. So that's going to be 10 oxygen, 4, and 6 oxygen is balanced. So it's already balanced. Now, once you actually balance this, okay, then only you proceed to do something else, okay, which is going to be, they say that you have a solution of 1 gram of washing powder. Okay, so 1 gram of washing powder, they actually require 7.15 cm cube, 0.1 mole per dm cube. Find out the number of moles. Okay, so if I have 7.15 times 10 negative 4 there, okay, so I am going to get, okay, 2 times 7.15 times 10 negative 4. What's the value?
1.43 times 10 power of negative 3.
Okay, so this is number of moles. Okay, so find out the mass. 1.43 times 10 negative 3 times with the MR of this. What's MR?
$83.99.
Please repeat.
83.99.
Okay, what is the mass?
$0.120.
So out of this 1 gram, I only have this sodium hydrogen carbonate. So if you ask me why 1, okay, because they use 1. Okay, so what you need to do is 0.120 divided by 1 times 100%, and you are going to get 12%. That's the answer. So the idea is be very sure what you're doing, and then just calculate as fast as possible. So it comes with practice. Okay, so you do need a lot of practice. Okay, please actually improve. You have 2 years, okay, to actually improve this. Okay, try a lot of questions. Please actually do it as fast as possible. Okay, let's actually go for the next question over here. This one, there's a lot of ways students actually can do this, okay? How to actually find the percentage of mass, okay? Whatever ways that you do, okay, please actually make sure that you need to do it as fast as possible, okay? So if you take time to do, then you need to actually change your method, okay? So please actually take note of this, okay? Now, so let's actually, I just write down sodium carbonate. This is sodium carbonate, sodium chloride, sodium hydroxide, sodium oxide. Okay, do remember that there is 2 over here. Okay, so if I want to actually find the 74.2%, yeah, so what I can do, maybe what I'll do is, let's say if I have NaCl, because this is only one, so let's actually find the percentage of B, for example, first. Okay, that's 23, okay, over 23 plus 35.5 times 100%. How many percent is that?
$39.3.
Okay, 39.3. That's not our answer. Okay, that's not our answer. So let's try the easier one, another one. Maybe we try sodium hydroxide. So 23 plus 16 plus 1 times 100.
57.5.
37.5. So definitely cannot be.
57.
57. Okay, definitely C cannot be the answer then. So what you need to do, you don't have any other option. You have to actually, okay, please select this one then. Just try, okay, because we want it to be fast. So 2 times 23 is 46. Okay, divide by 46 plus 16 times 100%.
74.2.
Yeah, D will be the answer. Now I told you I'm trying to actually do something to save time. So of course, I'm not going to actually spend my time to look for that once I have the answer. Okay, so please actually strategize yourself. If you want to do one by one, then it will take a lot of time also. Okay, please actually do your own strategy. Sometimes you have a question where all of them are sodium alone without times by 2. There is also a way to do. Okay, just be more creative on your calculation. Please do something about it. Okay, for this one, the answer is D. Okay, let's actually move on. Okay, now which mass of gas, okay, will occupy a volume of 3 dm cube? Okay, 3 dm cube. They say that 1 mole will occupy 24 dm cube. So 1 mole, 24 dm cube. So if 1 dm cube is actually 1 divided by 24, if 3 dm cube, it means this one times by 3, so 1 over 8. So we need to actually calculate so that you get 1 over 8 mole. Okay, it means anything that can actually give me 1 over 8 mole will be the answer over here. Okay, so actually, if you look over here, 3.2 divided by, okay, this one is 16 plus 16 is going to be 32. Okay, so that is going to be you get about 1, so that will not be the answer. Okay, we want 1 over 8 here. So the next one, 5.6 divided by is it, please check, N, nitrogen is what, is it 14? 14 plus 14, 28. 5.6 divided by 28, do you get 1 over 8?
No.
No, so that will not be the answer. So 8 divided by 32 plus 16 plus 16, so that's going to be 32 also. So 8 over 64, so that's going to be 1 over 8. That will be the answer. So once you are totally sure of the answer, you won't need to actually, unless if you have extra time, please come back over here to check whether D or whether you have made any mistake. Okay, so next, okay, let's actually move on to the next part. Let's see whether I can finish. I think should be able to finish. I selected another 2 more questions. Okay, let's actually see. Household bleach contains, okay, this one. The concentration can be determined. Okay, so they say that 25 cm cube is treated with excess. Okay, this is excess. And then they say this one is given off. So 0.0350 is given off. So we just want the concentration. I think it's a very easy question. Yeah. So you want the concentration of this bleach. Okay, this one. So what you need to do is 1 mole is 1 mole. So it's 0.0350 mole. And then there's 25 cm cube. Okay, in 25 cm cube. Okay, so just concentration is going to be, change this into dm cube. Okay, so 2123 0.025 dm cube. So divide, and what do you get?
1.4.
It's a very easy question. Okay, I thought they wrote a lot of things. Okay, maybe it will be challenging, but do remember sometimes it happens in that way also. Okay, sometimes they write a lot, but it's actually a very easy question. Okay, now the next question. This is actually something like, why sir, we didn't actually learn hydrocarbon, why? Do remember, this kind of question can be also be asked, okay? Because it's part of your calculation, okay? Hydrocarbon you have learned in IGCSE. So let's actually try to solve this, okay? Hydrocarbon, okay, so it's supposed to be hydrocarbon. They can be C and H. So just put CXHY. Okay, and then they undergo complete combustion. So complete combustion means they react with oxygen to give you carbon dioxide and water. And then they say that you have 35.2 gram of carbon dioxide, 14.4 gram of water as the only product. So what you can actually do over here is you can actually find out, okay, what is the number of moles of carbon dioxide. You can find out what is the number of moles of water first. Okay, let's actually find out first. Number of moles of carbon dioxide equals to
0.8.
okay. Number of moles of water.
0.8.
Okay. Now I want you to think what is going to be the next step. Okay, there are so many ways that you can actually do this. Okay, but let's actually see what is obvious over here. So let's actually see that is I know there's X and Y. So I know carbon, okay, this one must be X. Okay, must be always X. And then Y, so this one is Y. So this one, so maybe if I put Y over 2, then I'm going to get Y. Okay, of course I'm not balancing the oxygen yet, so I don't know, just leave it. So now I know that, okay, if you have 0.8 moles here, and if you have 0.8 moles here, you try to relate to X. Okay, X, if this one is 0.8, it means X carbon will be something like 0.8. Okay, how about Y? Y over 2 is 0.8. Y is what? 1.6. 1.6. So what do I have over here? Carbon, hydrogen. The ratio is 0.8 and 1.6. So let's actually find the ratio. The ratio 8 and then 16. 1, 2. So it means that carbon, hydrogen, 2. It means this is going to be the empirical formula. So please actually check which one that will have the empirical formula of CH2. Which one? A also CH2. This one also CH2. Cannot be this, cannot be this. So what is your next step? The next step is, okay, do remember, we missed this part. Okay, they said that 0.2 moles. Okay, 0.2 moles. Okay, they actually give you 0.8 moles here, 0.8 moles here. So it means this one is actually 1, correct? So if this is 1, I think if we have this value, no need to even use this one. Okay, when we have this value, if this is 1 and this is 0.2, how to actually get 0.8 over here? So what is X? Frederick?
Haven't calculated, sir.
Yeah, you see this one is 1, right? Okay.
Yeah.
And we know this is X.
Mm.
If this one is 0.2, okay, and then I know this one is 0.8. Okay, what is X then? Can you see the increase is going to be times by 4?
Yeah.
So X is what?
4.
Yeah. This must be
Oh.
always 4. So once you actually find that 4, okay, that is actually where the empirical formula, just put 4 there. C4, okay, it means it must be C4. And then H8. Okay, I'll let you guys to see a bit, okay, about the working and so on. Okay, please actually digest this. Okay, the thing that I want you to highlight over, I want you to see over here is, they say that this is, we have calculated 0.8. Okay, 0.8. And we know that this is 0.2. So if this is 1, in order to get 0.8, it means this value must be 4. It means I have identified my X as 4. So once you actually identify that X is 4, okay, so this is X and Y. So if I put 4, it means that's going to be your C, must be always going to be, you already know that is 4 already. Okay, you just CH2 is the empirical formula. So X must be always 4. So if it is 4, it means everything times by 4. Okay, C4H8. Is there any question on this?
So how'd you get 1.6 for H?
Yes. For H, you get 1.6. Can you see here? This is 0.8 and this is 1.6. Okay.
How do you get 1.6?
How do we get 1.6? Because you see here, the total number of moles is 0.8, correct? Here we count just now 0.8. So I know that this is Y over 2. So I counted, okay, the Y over 2 equals to 0.8. So I found Y equals to 1.6. So first of all, I find the relationship between between carbon and hydrogen first. Okay, and then I know this is going to be 0.8, but I didn't check properly that I have this value. So once I have this value 0.2, I can definitely be sure that my X value is 4. Okay, it means C4. Okay, so if you have CH2 as your empirical formula, if you have C4, then H must be 8. We will try more questions on this. Okay, just please actually check on this as well. Yeah. Owen, is that okay now?
Yeah, already understand, sir.
Yeah. Anyway, there's another 2 more minutes only. Okay, I want you to get ready. So Miss Andrea will